As I've demonstrated in the section preview video, we will now have 3 petals in our basket that will make up our basket. So I actually want to start off this video with an exercise. I want you to set up the components with some offset so that we have the results that we've seen in the preview. So go ahead and set the component attachment so that there are 3 petals that will make up the basket pawn. You also want to define an offset between the petals. Of course, you want some space between the petals. I used 150 units of offset. That is in the positive z-axis in the demonstration. I'm also adding difficulty to these challenges, so this is going to be a bit more challenging because you may have to experiment a bit with this. The difficulty takes into consideration the target audience for the course, so in this case the course targets beginners, so as a beginner you may have to experiment a bit to get the setup that we want for this. But of course this is not that difficult, it might just take you some time to get that setup that you want. Alright, so go ahead and try this, and when I come back I will show you how I set this up. To begin, I will duplicate the petal variable along with the uProperty macro and rename those so that we have petal 1, petal 2 and petal 3. I will also create a petal offset variable which will be of type fvector. I will decorate that. We will talk more about the specifiers for this petal offset variable a bit later on. I will initialize the petal offset variable in the constructor since the class has components and we initialize and set things up in the constructor anyway. You can use fvector for the initialization with the z component set to 150 for example. You should actually be fine by just passing in 0, 0 and then 150 as well. Next we create the default sub-objects, and to save some time I will copy the assignment for petal 1. That statement I will duplicate that and I will rename, also making sure to rename within that text macro. The next step is to set up the attachment. Again I will copy that line for petal 1. This is where you may have run into some issues. If we attach every petal to the root component, we will not get the setup that we want. Instead I will only attach petal 1 to the root component. Then I will attach petal 2 to petal 1 and petal 3 to petal 2. Finally, I will set that relative location for petal 2 and petal 3 by passing in that petal offset variable that we have created. This is what will give us that gap between the petals. I will build and run that. Back in the editor, I will open up the basket blueprint. This is an old habit of mine to use the content browser. It may actually save you some time if you click to edit the blueprint in the world outliner, since an instance of that basket already exists in the level. For petal 2 and for petal 3, I will set the petal static mesh and material. Notice that under the class defaults, under setup, the petal offset now shows up, but that actually won't give us the result that we may expect at the moment. I will talk more about that later in the lecture. Back in the level editor, I will view my placed camera actor and reposition my basket to about -600 in the z-axis. I will exit the preview and save all. Let's go and test this out. Observe that we do get some collisions, and the apples do get destroyed when they collide with the bottom petal, but the apples simply collide with the top 2 petals. They don't get destroyed. In other words, they don't get collected. As an exercise attempt to fix this, we want the apples to get destroyed when they collide with any one of those petals that makes up the basket. If we navigate to the basket base implementation, remember we have this onHit function that we use as a callback for onComponentHit. We can duplicate that for every petal, rename and bind that for every petal. Now we have one onHit function that we can invoke, onComponentHit for every petal, save those changes and recompile. If we playtest, we still get the same behavior as before. You may want to take a second to think about why that is. Recall I mentioned that we need to ensure the simulation generate heat events is enabled. This is per component. So back in the basket blueprint, I will enable that for every pedal, so for pedal 2 and pedal 3, since those will not be checked at the moment. Compile and save. And if we playtest now, those apples should get destroyed when they collide, so on hit, with any of the pedals that makes up the basket pawn. Mission accomplished. We get this annoying warning that you may have noticed. Current velocity will be initialized after pedal offset. Before we fix this, I will modify the initialization and pass in doubles instead of floats, since that is what the IntelliSense tells us that this accepts. This will basically be an Effector 3D, so not the one that has float members, but the one that has double members. There are some changes with these from Unreal Engine 4 that I'm still getting used to. Next, we can do a couple of things. We can initialize in the body of the constructor. We can swap some of these around to change the order, or we can initialize in the body of the class definition. I prefer to initialize in the constructor in this instance, since we set up the components and everything else here anyway. That is for this particular class, so if I have components, I prefer to use the constructor for all of the initializations. But instead of doing all of that, I'll actually try to do some reordering in the header and clean that up a bit so that it reflects the order of things in the constructor, so the initializations in the constructor. We have the basket speed and the pedal offset declarations. Remember, we also have the current velocity in the private section. To match that in the constructor, we can initialize the current velocity last in the constructor. You don't really have to do this part for the warning, but I will move the variables up so that they are declared before we declare the pointers for the components. That again is to match the order of what we do in the constructor. This is mainly for readability, but we will notice that if we have the order of the variables, the declarations of the variables, in the same order in the class definition and also in the constructor, then that warning should go away. If we rebuild using live coding, the warning may not go away. So I'll close the editor and build and run from Visual Studio. The warning does not show up in the output anymore. Back in the editor, I will select the instance of the basket blueprint and navigate to the setup category. We have the pedal offset here, and notice that if I modify the offset value so as to not reflect in the editor, the modification also does not reflect when we playtest. This is because the constructor uses that default value that we have set for the pedal offset variable. Modifying that variable later on changes the variable but not the initial construction of the basket instance. For iteration purposes, it would be nice if we could get the offset between the pedals to reflect, at least when we playtest, so that we can decide on what initial value to use for that offset. If you think about it for a second, we can always do an initial offset and then another offset on begin play, so that is what I will do. I will copy the set relative location statements and paste those in the begin play function. Save those changes and recompile. Also notice that the warning still does not show up, so that should be fine now. Now if we change the pedal offset, the set relative location takes effect. I will actually undo those changes, so I will remove the set relative location statements from the begin play function, and I will save all. What we've done here basically works. It is fine for testing purposes, since once we have the offset that we like, we can go back and hardcode that on the C++ side of things if we want to keep those changes. To end this lecture off, however, I will leave you with an exercise where we will end up with a more useful setup that is for iteration. For this exercise, I want you to find and override an appropriate function that is other than the begin play function to set the relative location for the pedal components. Basically what we want is that when we apply a modification to the pedal offset data member, the modification should reflect in editor time and also during gameplay. The difficulty here is a bit silly. I set that to hardcore. That is just because you may have to do some research experiment, and as a beginner you may not have had many opportunities to actually apply some of what you may have learned in the basics of C++, such as overriding functions. Here you will actually have to apply that and do some testing. In addition to inspecting the interface file, so reading the header file, you may also have read the AActor documentation. And if we scroll down, we have this remarks section, which will list out the order of important virtual functions that get called. So for example, on begin play, that is a bit too late to set the offset for those components. That might work for you. It's perfectly fine if you want to do it in that way. Maybe change the variable and then playtest to see how that will look and how that will work. And then you can always go back to the C++ file and update the default value that you used to initialize that particular variable with. But you can also try some of the earlier functions, so you can go up, so you have initialize component, pre-initialize components, and so forth. And then eventually you can see that you have the pre-register all components. Alright, that is going to happen before you actually register the components. So it is useful to use a reference such as this if you are looking at some of these functions. Of course, we don't always remember the order of these virtual functions when they get called. Virtual is the keyword here because that means we can override that function in AActor. Alright, to begin I will navigate to the basket-based interface and I will override the pre-register all components function. Create the definition for that in the implementation file. I will call the parent. We will use super. If you don't remember, you can always check the begin play function for how it is done. I will leave the initial configuration in the constructor, although it should work fine even if you remove these statements. I just want to enforce that construction. Next, I will set the relative location in the pre-register all components function. Build and run. Back in the editor, I will select that basket instance and navigate to the setup section again. Notice that if we modify the paddle offset now, it actually reflects in the editor. I will set the value of the Z member to 250, for example. Press enter, and notice it actually updates in the viewport now. That modification should also reflect when we playtest, even though we are no longer setting the relative location in the begin play function. I will exaggerate this a bit by setting the Z component to positive 300. This is what super easy mode may look like. I can even revert back to the original value and it will update. Of course, this is very useful for iteration. This is getting fun now, right? This exercise was actually not that difficult, but I measured this keeping the beginner in mind. People generally do not have the patience to experiment and find things on their own. So congratulations if you have managed to complete this exercise by yourself. You are well on your way to get to that point where you can work independently as a professional programmer. The goal with these kinds of exercises is really to get you to a point as a programmer where you need less hand-holding when working on your own projects, less need for tutorials and courses on every single thing that you are trying to implement. Through observing what you have available, typically searching header files, reading documentation and comments, and through experimentation, you will find what works to solve the problem. Sometimes we don't get the results that we expect, and so we need to keep trying different things, really take a step back and think about what we are doing, look at what we have available, read the documentation, and then experiment to try and solve that problem.